Hello, everyone. Welcome to the session. Welcome to the first IaCConf, of course. My name is Emin Alemdar. I'm the CNCF ambassador and also an AWS container hero. And with me today, I have my colleague Flavius as well.
Hello, everyone. I'm Flavius Dinu. I'm an AWS community builder and a Docker captain. I worked as a DevOps engineer for more than 8 years, and I'm very passionate about infrastructure as code. And I'm based in Bucharest, Romania.
There we go. Now, for the session itself, let me share my slides. I hope everyone can see it right now, but this session, we're going to basically go over getting started with IaC, and of course, in the agenda, this is the boring slide. We're going to do an introduction to IaC, and of course, we're going to discuss why IaC matters actually, and we'll see the tools in the ecosystem, and we have chosen one of the tools, OpenTofu, and we'll talk about why OpenTofu is important. And of course, we're going to explore some of the contents of OpenTofu, like resources, providers, inputs, output variables, the importance of the state itself, and of course, locals. And we're going to have a demo. And lastly, we're going to discuss why IaC is not enough on its own. And like we told you, this is who we are. You can scan the QR codes to access to our social media accounts if you want to follow us both. All right. Then we can start with introduction to IaC. So basically, IaC means infrastructure as code, and it's the practice of managing and provisioning computing infrastructure, including servers, including the network infrastructure, databases, storage devices, etc. And it's instead of using the cloud provider consoles or anything like that, you use code rather than through the manual processes. Instead of ClickOps, you can automate some of the stuff with infrastructure as code. So why infrastructure as code matters? Because it brings you that automation aspect. So you're going to be able to automate the deployments of your resources with infrastructure as code, and you can have the flexibility of easily duplicate environments. So you don't have to manually create every resources one by one for each and every environment. You're going to be able to maybe change some parameters and then duplicate the environments, for example, for your test environments or for your production environments, etc. And you're going to have consistency. And of course, with the consistency, you're going to have standards for the resources themselves too. You're going to have that standard of having the same resource type, having the same, for example, instance type for every environment you have. And of course, you're going to be able to version control the code itself. You will be able to collaborate with your team members. You'll be able to review some of the changes, and of course, you'll be able to have that version control under Git. And it'll also reduce the configuration errors because it'll reduce the human error too. Of course, you can make some errors while writing the code itself, but instead of going through the manual processes, since you're going to have the IaC, you're going to be able to review those changes before even creating the resource itself. And you'll be able to iterate best practices between different environments too. And of course, most importantly, you'll be able to have the documentation of a resource in the code itself too. Good. And what are some of the tools in the ecosystem? We have different tools such as OpenTofu, Terraform, Plumi, CloudFormation. For example, you also have some cloud provider specific resource IaC tools such as CloudFormation, Bicep. Google has its own too. But we, for this session, we just decided to focus on one. And it is OpenTofu. And why we want to choose OpenTofu, let's start with what is OpenTofu basically. OpenTofu is reliable, flexible, and community-driven IaC tool under the Linux Foundation stewardship. It serves as a drop-in replacement for Terraform, preserving your existing workflows and configurations. Why OpenTofu? OpenTofu recently joined CNCF as a sandbox project, and as a CNCF ambassador, I can only encourage you to at least test it out. But basically, with this open source mindset, with the steering committee OpenTofu has, the community is going to be listened by the steering committee, and also the features that the team, the OpenTofu team, will implement is going to come from the community itself. And of course, to be able to get involved with the project itself, you can of course visit the repository. You can of course check out the website. You can create some issues for maybe some of the resources you. Some of the features you want that team to implement, you can reach out to them very easily. You can also join the OpenTofu Slack channel, but basically, and like I said before, it's a drop-in replacement for Terraform. It's an open source alternative to that. So let's look at some of the important parts of the OpenTofu language. So first of all, it has resources. Basically, this is the most important element in the OpenTofu language. And each resource block describes one or more infrastructure objects, such as virtual network components, the instances, or database instances, etc. So you define the resource block. For example, I have a resource block for a Kubernetes pod here. As you can see, I have my resource type, and under that, I also have my specification for the resource itself, such as the metadata, the name of it, and of course, which container image I want to use, which name I want to use for the container itself, which environment variables I need to attach to the container itself, which ports I want to expose for that pod itself too, right? And next, we of course have providers. These providers are basically plugins, and OpenTofu relies on these plugins called providers to interact with cloud providers, SaaS providers, or other APIs. For example, if you want to create a resource in AWS, you need to use the AWS provider to be able to connect to the AWS API. And of course, OpenTofu configurations must declare which providers they require so that OpenTofu can install and of course use them. As you can see in the example, I have my Kubernetes provider there, and I have my version, which version of the provider itself I want to use in my config. And of course, you can define all of the provider specific configuration in the provider block too. For example, the authentication methods we want to use. The next thing I wanted to talk about is, of course, the input-output variables. So input variables, these are basically environment variables. They let you customize aspects of some of the modules without altering the module's own source code. So this functionality allows you to share modules across different OpenTofu configs, making your module composable and reusable. So instead of hard coding every parameter in there, you can rely on these environment variables. And since we mentioned in the beginning, IaC allows you to have a standard between different environments, have a consistency between different environments. So you can use the same code, but by changing the parameters with these environment variables, with these input variables, you can have the same functionality with different parameters in different environments. And of course, for the input variables, you can define the variable block, such as in my example, you can define the namespace name, the pod name itself, you can define the type of the environment variable itself, and then you can pass the necessary information to your code. And similarly, the output variables, the output values make information about the infrastructure available on the command line. And of course, you can expose the information for other OpenTofu configs too. So almost every resource in OpenTofu has an output. So either it's the name, either it's the ID, either it's the, for example, for AWS, the Amazon resource name or something else. For example, you can export the namespace name, right, for the example we use here, and you can pass that output to some other configurations. All right. And one of the most important topics about OpenTofu is, of course, the state. So OpenTofu must store a state about your managed infrastructure and, of course, the resources and the configuration of those resources too. This state is used by OpenTofu to map real-world resources, the actual resource itself, and map that to your configuration. To keep track of the metadata, and of course, to improve the performance for larger infrastructures. So basically, the desired state is going to be your open state, OpenTofu state, and of course, you're going to have the actual state. So basically, the resources in your cloud provider accounts, and OpenTofu will allow you to have that mapping between the two. And OpenTofu uses state to determine which changes to make to your infrastructure. So prior to any operation, OpenTofu does a refresh, read the state file, and of course, update the state itself with the real infrastructure changes. So for example, you've created an instance, but let's say you want to change the size of the instance, or you want to change the disk size of that instance, right? You make the change in your code. And of course, once you trigger the workflow, you can update the resource, and OpenTofu will update the state itself for you. And the primary purpose of OpenTofu state is to store bindings between objects and in a remote system, and of course, resource instances declared in your configuration. And most importantly, one of the best practices about the state itself is to store that state in a remote location, and of course, making sure that that state is secured. For example, encrypted, or you can have necessary IAM configurations for other people to access that state file. So, for example, you can use a remote backend in the code itself, remote backend config in the code itself, and then store that state file in a secure location, for example, in S3 bucket, or Azure Key Vault storage, or blob storage, right? Or Google storage buckets, etc. All right. The other concept I want to talk about is, of course, the locals. The local value assigns a name to an expression. So you can use the name multiple times within a module instead of repeating the expression itself. So these are really helpful. As you can see, you can define that locals block in your configs, in your OpenTofu configs. And basically, these are similar to environment variables, the input variables, but you can have that and use them multiple times in the configuration itself. You can pass all of the local variables multiple times instead of repeating the expression. All right. Now, without further ado, this is the demo time. For the demo itself, Flavius is going to take up the stage, but we have a GitHub repository, so you can scan the QR code from the screen to access the repository itself. If you want to follow along, there are some prerequisites such as OpenTofu, kubectl, and of course the IDE of your choice. But before the demo, if we have any questions, we can maybe answer them. Then I can pass it to Flavius to show the demo. Let me see if I have any questions in the Q&A. There we go. Let's start with this one. So, Rodney asked, as an open source fork of Terraform, what is the expectation for OpenTofu to adopt new features moving forward? An example would be ephemeral resources. That's a great question, Rodney. Thank you for that. So, the expectation for OpenTofu to basically listen to community more and more, since those questions, those feature requests are coming from the community itself. The idea behind that is the steering committee will make a decision, and that decision is going to be the best decision for the community itself. And it is now a CNCF project, and following the CNCF guardrails, and every CNCF project basically follow the similar rules for every project, and it's going to follow the same guardrails. It's going to follow the same adoption rates and all of the rules for the CNCF projects. Right. And one of the examples for those features, for example, the state encryption, that was requested for a really long time. And after the fork itself, the OpenTofu team decided that they want to implement this feature for the community because it was one of the most wanted features, and they now have that in place. All right. Another question. Let me see. This one is also good. But do we expect that OpenTofu and Terraform merge in the near future, especially after IBM acquisition for HashiCorp? I really don't have an answer for that. And I don't know what's going to happen in the future, but we're going to have to wait and see, I guess. Let me see. This is also a great question. I'm not reselling Terraform. Why will I want to switch to OpenTofu? So if you don't have any problems with the license itself, the license change itself, of course you can stay on Terraform, but some of the features, such as the state encryption one I mentioned, and basically, if there are going to be feature differences between the two, right? And maybe you can see some features implemented in OpenTofu that are not available in Terraform, and that feature alone can be your reason to switch to OpenTofu, basically, if that makes sense. Let me see another one. Do you have any recommendations for generating IaC with AI? I've used a few tools, but I haven't found something that is as comprehensive as needed. That's the mystery of AI. Like we all use AI. We all use ChatGPT or something else to generate some code. I believe, honestly, like AI can be a great starting point to generate maybe the base of the code itself, but you can improve from that point on to make it as comprehensive as you need. I wouldn't expect AI to generate like an entire architecture, entire infrastructure component resources for you, but this can, like I said, this can be a great starting point for your IaC journey there. And also, instead of maybe working through some of the basic concepts, you can get started with AI and then move on from there, if that makes sense. Here we go. Some of the questions are already answered in the chat, so thank you, Flavius, for that. I'm looking at the question list again, so I don't want to miss anything. Any thoughts on using OpenTofu with MCP? To be honest, I don't have any experience with MCP at all, so I can't really answer that question for you, but maybe someone else in the chat, in the audience, can answer that as well. There we go. Another question. Is there any challenges that you faced on a complex environment of migrating from Terraform to OpenTofu? That's also a great question. So for the majority of the versions of both, there's feature parity. So in OpenTofu, in the OpenTofu website, there's also a migration guide from Terraform to OpenTofu. You can follow those instructions. You can follow those migration paths. Between those migration paths are purposefully built for different versions of Terraform and OpenTofu, by the way. So, for example, if you're on 1.6 version of Terraform, you can follow that guide. If you're on 1.9, etc., you can follow that guide, etc. Basically, it's mostly going to be a drop-in replacement, and you're not going to face any problems. Of course, there might be some edge cases. For those edge cases, you can also reach out to the OpenTofu team too. There we go. Another question. My company, 20,000 plus tech, is adopting TF now. Is there any downside to not using Tofu until we adopt TF? I don't think there would be any downsides to that because you can migrate to OpenTofu if you want at any point in time. I would again, as a CNCF ambassador, I would encourage you to at least test it out, test OpenTofu out. And if you, like I said, if you face any issues, any problems with it, you can reach out to the OpenTofu team. You can always create issues in the repository and things like that. Also, you can follow up with me directly after the conference, after the session, if you want. All right. Yeah, I think that's about it for the question. If I missed anything, I will take a look at the questions again, but I want to introduce Flavius again to the stage for the demo itself.
For this OpenTofu demo, we will use the Kubernetes provider to ensure that you will not incur any costs. I'm going to share the repository that I'm using in a moment, but you can also follow along if you want, and you don't need to download the code for that. The first thing we will need to do is install Minikube to create a Kubernetes cluster. I'm going to paste this link in the chat in a moment. So I'm using macOS, so I'm going to install it using Homebrew, so I'll just copy this command and paste it here in my terminal. Of course, if you're using any other operating systems, it's very easy to just, select it, select the architecture, and then just follow along the instructions on how to install it. Now that Minikube was installed successfully, we can create a Kubernetes cluster. So in order to do that, we have this command here called minikube start. I'm going to run it here. And we will wait a couple of seconds until the cluster is up and running. The cluster was created successfully, and as you can see here, kubectl is already configured to use Minikube cluster in the default namespace inside the cluster. So if I run like a Kubernetes get pods, we're going to see that there are no pods in the default namespace. I have this repository set up for the demo, but we will need to create OpenTofu files, so I'll do a main.tf first. You can actually do main.tf or main.tofus because OpenTofu can also read .tofu files, but because I'm not going to use any OpenTofu specific features inside of this demo, we can basically use .tf to maintain compatibility with Terraform as well. So in the main.tf file, you can basically add the logic of your code, but I'm not going to do that right now. We are just going to create the other files as well. We can do a variables.tf, so in here we will have all of our variables used by the main.tf file. We can also do an outputs.tf to expose different details about our configuration, and in the end we can create a providers.tf in which we will keep the logic of our provider. So as I said before, we are going to use the Kubernetes provider. So for that, I'm going to go to the OpenTofu registry, to the IaCConf Kubernetes provider. So you have this, how to use this provider here, and you can easily just copy and paste this one. As you can see, I've pinned the version to be equal to 2.36.0. But as a best practice, you can use the pessimistic constraint to ensure that only the most far upright version can be increased. So this means that you cannot increase the minor or the major version. Now that I've defined this, and this is, of course, as I mentioned before, a best practice, and you should always try to use it, because otherwise, for example, let's say a new version comes up, a new minor one, it may include some breaking changes in some of the parameters. This will make your code to fail, and people won't know why the code is failing, so that's why I recommend it. So after you are done with the version and you ensure the pessimistic constraint is here, or just a hard equal and no greater than and stuff like that, there are many ways in which you can configure your provider. So let's go to our registry again. Go to the overview here, and as you can see, we could do a config path and a config context. This is the most easiest way to do it. I'll just paste this here. The config path looks okay, so this is where I keep my kubeconfig file in the kube folder in my home. And the config context will be minikube for this example. Now we're ready to create our first resource. So to do that, I will actually go back to the registry here, and under core I'm going to select namespace. So we will start with a Kubernetes namespace first. Let's check and see. We have here an example. I will just copy this, paste it in here. So in OpenTofu, the first thing that you'll see always is the resource name, so the resource type actually, and then a name for that particular resource. So this can be changed to whatever you want. But this one, if you want to create a Kubernetes namespace, this is the way you can actually do it. I'm not going to add any annotations to my Kubernetes namespace. I will add a label though, so I'll say color equals to green, for example, and I'll do here a tofu namespace. So now I'm ready to do a tofu init inside of this repository. And the next thing I'll do after the plugin is downloaded is run tofu plan. And as you can see, a Kubernetes resource will be created, so a namespace will be created that has the color green. So now if I run a tofu apply and say yes, you can see the tofu namespace was created. So in order to check that out, we can do a kubectl get namespaces. And if you look here, you'll see that the tofu namespace was created 9 seconds ago. Okay, so we've created a bunch of files here, but right now we've used only 2. So let's declare a variable right now. So in order to declare a variable whenever you're using OpenTofu, it has to be prefixed with the var keyword. So let's say namespace name. I'll just copy this. And as you can see, Visual Studio is helping me out. It doesn't know who this variable is, so we'll have to declare it. And to declare it, we'll add the variable keyword here, add the name of the variable, which is namespace name. We can add a type here. I'll do type string, and we can also add the default value, and we will do the same as we used before. So right now nothing has changed. If I run tofu plan again, you're going to see that there are no changes and our infrastructure is matching the configuration. We can also declare an output based on this namespace. So let's go back to our registry and see what are the details that this is actually sharing. So basically our resource has a nested schema for metadata, as you can see here, and also has a name. And basically what we could do to create an output is go inside of our outputs right here. Let's move it to the right because it's easier to follow that way, and say output. We can add whatever name we want, but this will be a Kubernetes namespace name. It makes a lot of sense to add meaningful names because as you scale and you create more and more variables and outputs and stuff like that, this becomes really hard to follow. But if the names are very suggestive, it will be easy for other people to understand what's happening here as well. And in the output, you'll add a value. And the value for this case would be the resource type dot the resource name dot the field that we're interested in, which is metadata dot, I guess it's name, or it's name. Now if I run tofu apply, okay, it's .0.name. Now if I run tofu apply, you are going to see that this Kubernetes namespace name is tofu namespace, and I can say yes. So right now we are using all the files that we've declared right here, and this is a very simple example. In order to delete this namespace, we can actually run tofu destroy, and it will get destroyed in a couple of seconds. Now I'd like to show you how to link different resources together. So we have a namespace here, but I would also like to add a pod in this newly created namespace. So let's go back to the registry, select pod, and then go to the example usage, which is at the bottom of the page. I'll just copy one of the examples right here, and I'll just paste it here. I will change the name of the pod to something like this. Name of it, this will be var.podname. Here we can leave this as it is, remove the environment because I don't care about it. We can open the container port to be 80, that's good. I don't care about any liveness probes right now because this is just a simple example, and I don't care about any DNS config at this point. So now what we need to do is declare the variables. So I'll just split this to the right and say variable pod name, type is string, and for this one I'm not going to add a default value because I want to show you how to use terraform.tf vars. So in the terraform.tf vars file, what you do is you add values for your variables, and even though this one, for example, has a default value, if I add it here again, this value will be overwritten. So if I do here like namespace name, and this would be tofu ns, for example, and we can do here pod name, this would be nginx, you will see that the namespace name will be tofu ns. But if you look here in this example, I forgot to add the namespace of this pod to be this one from above. So as far as I know, we'll have to add it here. We can always double check inside the documentation. So we could do something like a search, it'd be faster that way. So I just missed it. So it's this one. Defines the space within which name of the pod must be unique. So in the metadata, we have this field for the namespace. So let's go back and add it and say namespace is Kubernetes namespace.this.metadata.0.name. So basically we have created a link between these two, and OpenTofu will know to create this one first, and after that create the other one. So if I run a tofu plan, you will see that the Kubernetes namespace name is tofu ns. It was overwritten by terraform.tf vars. And if we look here at the pod, we are going to see that the pod will be created in the tofu ns namespace. So now if I run a tofu apply, we are going to see that the namespace started to be created first, and then it was created, and only after this one was created, the pod starts to be created. So this will take a couple of seconds to be done. So as you can see, the pod is also created right now. Check that out. You can run kubectl get pods -n and say tofu ns. And you can see here the nginx pod is up and running. What I want to show you now is how to create multiple resources of the same type using count and for each. We'll start with count. I'll just comment this part out, but we will start with the namespaces. And let's do a count equals to 3, for example. So this will create 3 namespaces. Count equals to 3 means that this will iterate like this for I in the range of 3, and I would be first, in the first iteration 0, in the second one it would be 1, and in the third one it would be 2. So let's not use a variable for now and say something like this would be ns-$count.index. And in this case, count.index will be 0, 1, and 2. And now if I run a tofu plan, you're going to see that I forgot to remove the output as well. So I'll have to remove it from here. And we can go back and say tofu plan. You will see that 3 different namespaces will be created: ns2, ns1, and ns0. This is really great, but it's not very practical in a real-world example, especially if you would like to have different names or different other parameters. What you could do is you could use locals, or you could use other variables as well, but in local blocks you can actually hold different expressions, which would make this a very good example. And we can create here a list, let's say Kubernetes namespace names, and this can be equal to ns1, ns2, and ns3. And the count won't be equal to 3 anymore. It will be equal to the length of local.kubernetes namespace names, and the name would actually be a local.kubernetes namespace names of count.index. So the length of the list is 3. So again, we will have the same example as we had here before, and the name is going to be the list. And in the first iteration, it will be the list using the element from index 0, which is this one. Then it will be this one, and in the end, it will be this one. And now if I do something like tofu plan, you are going to see the namespaces will be ns3, ns2, and ns1. Well, let's apply this code and create the namespaces. And now I'll show you one of the reasons for why you shouldn't usually use counts. So as you can see here, the names of the resources, the identifiers of the resources, are created using these index right here. So this behaves exactly like a list. So if I want to remove the middle item from here, what's going to happen is the last item will change its index and it will have to be recreated, which is not so bad in this example because I have only 3 elements. But imagine if I had like 100 elements in the list and I wanted to remove the second one. This means that every other element from the third one to the last one will be recreated, which would be a very, very bad thing in your infrastructure, right? Because you will have downtime. All these resources may have other dependencies that you are not aware of at that point in time, and these things would be just catastrophic in the end. And if I do a tofu apply, you're going to see that the one resource will be deleted and the other one will be recreated. So let's do it like this. We're going to see there is 1 to add and 2 to destroy. Of course, because the second index is now out of range and this one changes the index from 2 to 1. So in practice, one is changing and one is getting destroyed, but by changing their identifiers, 2 are getting destroyed and 1 is being created. So if I do this, we'll have to wait a couple of seconds for the namespaces to be destroyed, but after that, the NS3 would be created, but at index 1 right now instead of index 2. Now let's destroy everything, and let me show you how you can use for each for that, to make it even more easier to manage all of these resources. So for each actually works with sets and maps. So we are going to remove the count from here and say for each, and we will do a toSet to my local.kubernetes namespaces names. So this will change the type from list to set, and the name in this case would be local.kubernetes namespaces name of each.value. So basically, when you're using for each with a set, it exposes an object called each.value, which would be on every iteration different based on how many elements you have in that particular set. So let's add NS2 back here again. Let's also do like an NS4. And if I now run tofu apply, you're going to see that there is an issue. And of course there is an issue because I'm doing each.value, but each.value is already this element, so I don't need all the details from here that I've used before. So if I do tofu apply again, you are going to see that 4 different namespaces will be created. And if I do yes here, you're going to see that all got created successfully. But now if I remove one of them, because their names are not formed as a list as it happened before, only the second one will be deleted. And if I do right now a tofu apply, you're going to see that only NS2 will be destroyed. Great. I would now like to show you how to conditionally create resources, but to do that I will destroy everything for now. So OpenTofu has ternary operators that you could use to conditionally create resources or to conditionally create different expressions. So for this example, I will just conditionally create this resource. I would do something like, let's keep the locals block actually, and do a create namespace equals to true. Actually, let's do equal to false first and say local dot create namespace. This would be the condition basically, so you'll have to use a question mark after the condition. So this checks if local.create namespace is equal to true, and if it's true, we are going to create a namespace, let's say NS1. Otherwise, we are going to do an empty set here. So if I now run tofu apply, you're going to see that there are no changes because my infrastructure matches the configuration. Because this is equal to false, it will go after the semicolon right here to this expression. So this would be an empty set, so no resources are here. But if I change this value to true, you're going to see, if I run tofu apply, that one namespace will be created. This actually works with count as well. You can use it again, as I said, in different expressions. You could do whatever you want with it. So it's very, very useful to know that you can use it. Now that you have some understanding of how HCL works and how easy it is to get started with OpenTofu, I would like to show you something that OpenTofu does really, really nice, and is this .tofu extension. So what happens here is, if I'm using both main.tf and main.tofu, when we are running tofu plan or tofu apply, when there are 2 files with the same name but have these different extensions, OpenTofu will always use the .tofu one. So you can see here I have this conditional added, right? But I'll just do this one like so. And now if I run tofu apply, you're going to see that this one will be taken into consideration and this one won't be taken into consideration. So if I do tofu apply, you're going to see that I'm creating a namespace with color green that has the namespace name tofu ns as we've defined before. So as a best practice, you can use the .df extension, but if you want to use OpenTofu specific features, because there are a couple that OpenTofu has and Terraform doesn't, you can do a .tofu as well. In this case, you can build more robust modules, and they can actually accommodate both Terraform and OpenTofu. And in cases, again, as if you want to use different features that are not available in Terraform, you can do it easily with the .tofu extension. So let's now go back to the providers.df file. So in here, usually this is the place in which you're going to add remote state. In this example, I've used local state only, as you could see. But whenever you're using OpenTofu in production, it's a given that you're going to use remote state, because with local state there are many things that could go wrong. So you shouldn't apply OpenTofu code from your local computer when you're using it in production. You should always have remote state, because remote state comes with locking mechanisms. You're going to get protected to not have concurrent operations on your state, which can be very destructive when two people are doing different things on the same state at the same time. There are many things that can go wrong, and this is just a given. So keep in mind that you would always need to use remote state. So this is it for the demo. OpenTofu is great on its own, but you are missing critical layers like security, compliance, auditing, deploying mechanisms, integrations with your cloud providers, and other safety mechanisms. So if you're using OpenTofu, you still need to use a CI/CD or an infrastructure orchestration platform to help you get your infrastructure code safely to the cloud.
There we go. We're back.
Yeah. So I see we still have a couple of questions in the Q&A. So I'll just start with one, and maybe we can just, you take one, I take one, and if we have anything specific to the demo, I'll just, answer them. So do you recommend any AI tools which have a more complete view of the entire directory or repository? So usually code assistants do that, like Amazon Q, for example, or Codo. Or I also know about a tool called StackPack, but I haven't actually used it. I can actually, just paste the link in the chat. But yeah, I mean, these are the tools that you could use. Usually, whenever you want to see the entire directory or the entire repository, you should use a code assistant that has that has access to everything in the directory. Cursor AI is also good. Windsurf should be also good. So there are a couple from which you can choose from.
Yeah. Cool. Maybe let me just look at the questions again. We have a couple of more slides, but we just wanted to go over the questions to be able to basically answer all of them if we can. But like I said before, you can reach out to us after the session and ask any questions you have too. Let me also share this one. So do we have any open source tools that generate IaC for your existing infrastructure, taking into account the modularity and coding/project structure best practices? Honestly, there are some tools. I've also used some of the tools in the past to basically go over the cloud provider API and then create the necessary IaC configs for those resources. And some of those tools were really nice, but it wasn't following the best practices. It wasn't following the modularity. So I had to review the code myself, and of course, update the code itself after it's being generated. And of course, you also need to consider the fact that you need to import those resources into a state file to be able to keep it consistent with your OpenTofu, with your OpenTofu state. So basically, to reduce the drift, you can generate the code itself. You need to check every configuration aspect. And also you need to update the code if necessary, and then import the resources into the state file to eliminate the drift effect.
So just to add a little bit on this one, so I saw some people were writing Terraformer in the chat. So Terraformer is really, really great for importing your resources. But last time I used it, but this was like 1.5 years ago, it wasn't very, very good at writing modular code or, just respecting best practices and stuff like that. It's really good for importing the resources, but you still have to do the changes yourself, in the code to make it respect your standards.
Yeah.
Okay.
I can share another one.
Oh, okay.
If you want. What's your most requested feature for OpenTofu or TF? The one I mentioned during the presentation, the state encryption thing, which is now available in OpenTofu, that was for a long time the most wanted, most requested feature, and the issue in the original Terraform repository was like open for years. I can't remember like since when, but that was there for years, and the OpenTofu team have implemented it. So it is available in OpenTofu now. Anything you remember, Flavius?
No, I guess state encryption is the most important thing, and from what I recall, we were asking for state encryption since like 2019 or 2018 even. So, yeah. A lot of time.
Good. Yeah. Questions in the chat. For example, for Kubernetes GitHubs, how Terraform fits in alongside Argo CD/Flux CD. So let me put it this way. So for the Kubernetes cluster itself, I mean, like provisioning the cluster itself, either it's EKS, AKS, or the vanilla Kubernetes cluster you've created with kubeadm, right? You need some sort of infrastructure, including the compute, the network, the storage, etc. So you need IaC for that, right? To be able to making it more robust, making it more generic, making it more collaborative with your team members. So after creating the cluster itself, then you move on to deploying to resources to your Kubernetes cluster, your workloads, basically, your deployments, your pods, etc. So that way, you can then move on to using Argo CD or Flux CD to deploy the Kubernetes resources.
And in some cases, I also saw that people are using a lot of Kubernetes operators to deploy cloud resources, and that's fine. But still, if you are using the Kubernetes operator, for example, in Azure, right, you still need to have the managed identities created beforehand, and that's where you'll need something like Terraform or OpenTofu to help you, or even Pulumi. So you still need to have that infrastructure created beforehand before you can use the operators themselves, because of course you want to respect like role-based access control principle to have the least amount of privileges. And yeah, without Terraform or Pulumi or whatever other infrastructure as code tool you are using, this is not going to happen.
Yeah, this question actually brings me to the final section of the session. So if you can like bring up the final slide, please. Yeah. So we also wanted to discuss why IaC is not enough on its own. So basically, how can you bring your IaC to the next level? So for this, you need actually a lot of a lot of improvements over your IaC. So writing the code itself is not enough. So you need orchestration around the deployments of your IaC. And of course, you need automation. And you need collaboration with your team members. Someone should review the code. You shouldn't basically work alone. You need version control to store the code somewhere in some centralized location. And you need guardrails around the deployments and, of course, around the resource configurations too, right? And also, you need a state management strategy. We both said during our sections, you need to have a remote state location, like an S3 compatible storage solution to store your state. And of course, for the state management itself, you need to secure that location. You need to secure that, for example, the S3 bucket. You can encrypt the state itself. You can put a locking mechanism around it. AWS offers that with DynamoDB. You need to have the necessary IAM permissions and roles for your users, so no one can access that state file on their own. You need also remediation, and also, of course, you need visibility over the resources you've been deploying to your cloud provider account to be able to also have close control over the resources too. So you don't want anyone to basically deploy 8x large instances in your AWS account. You don't want to get shocked at the end of the month when you see the AWS bill, for example, right? And of course, you need observability, especially you need notifications about deployments, about the IaC deployments. And most importantly, last but not least, you need centralized management for your entire infrastructure management. All right? Let us also look at the questions, but if there are no questions, we can.
We have a question, so
Okay.
let me share it. But you guys are not going to like the answer to this one. So I guess for me, it depends how you're structuring your repository. It depends on how big your organization is. It depends on how many team members are working on it and stuff like that. There are many people that will come in and say, okay, you need to do it like one monorepo for everything, or do polyrepos for absolutely every service and stuff like that. What I can tell you as a best practice, at least in what I saw in 8 years working with Terraform, is the fact that your modules need to be in their own repository, because in this way they can be easily versioned, they can be easily tested, and you can easily use different versions of them in different configuration. So, because let's face it, whenever you do a new change to your module, it will be first deployed in the dev environment, right? Because you want to ensure that everything is working fine. And your QA, prod, stage environments, they will have other versions of that particular module until it's ready to be promoted. So keep the modules in separate repositories. For your environments, you can do a lot of things. There are actually a couple of sessions that I think will touch upon this. So yeah, Emin, do you feel like you can add anything on this?
Like you said, basically it depends on multiple parameters, just like Flavius mentioned. But I also recommend separating the codes for different environments, for maybe different business units, for different services, etc. I think it's the best practice too, because if you put everything into a single repository, a single monorepo, right, it'll be really difficult at a point in time for you to basically go over the changes So you won't be able to find what you're looking for at the end of the day in that huge mono repo. And if you have a centralized deployment methodology for that single mono repo, the plans, the applies, it's going to take forever for you to basically just 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 go over the state, like the refresh the state stage of the deployment itself is going to take forever. And like I said, again, like this slide is really what you should look out for your IaC journey. So you can test out the IaC, but if you want to manage your production environments, you definitely need some centralized management, some version control, some collaboration, some automation, orchestration, and of course, most importantly, guardrails around the deployments for the IaC too. Are there any other questions?
There is another question about AWS recommending cloud control provider. What is the opinion on this provider? As far as I know, this is not very mature, but I haven't had a chance to actually use it. So maybe you, Emin, know something about
I
it?
haven't used it. I haven't used it either. I've just heard some use cases around this, but I haven't used it actually.
Yeah, I guess it depends on, again, what you want to do. If you're looking for governance, for example, Open Policy Agent can be a great option for that.
Mm-hmm.
I don't know. Depends on what you're planning to do with it.
Yeah.
There is another one. Best open source tools for drift detection. So I'm not aware of any good open source solution for drift detection, to be honest.
Yeah. Yeah.
So
I
we're
don't
not
think so.
going to be able to answer this one.
Yes, unfortunately.
Yeah, there was Drift CTL. At some point, it was doing a good job, let's say. There are solutions out there, however, that offer very complex drift detection and also remediation. So yeah, if you're pairing your OpenTofu code with an infrastructure orchestration platform, you'll most likely get drift detection, which is fundamental in my view for building a secure environment for your infrastructure.
Yeah. The demo is really great. That's for you, Flavius. Thanks. Is this live stream going to be available in YouTube or somewhere we can review later? I believe these sessions are going to be uploaded to YouTube, and of course the slides will be available for you, so you can get access to the session after.
I see another.
Okay.
I see another comment about using Atlantis for your Terraform orchestration. And Atlantis is an awesome tool. I really use it a lot in small projects, and it does a great job in small projects. But as soon as you scale, there are some issues with it. So, for example, with Atlantis, you don't get policies. So you don't have like a policy as code offering there to help you be in control of your resources, to like control what kind of resources people can create or what kind of parameters they can have. So with Atlantis, you cannot do this out of the box. And imagine if people are just coming in and doing this PR review and they have to spawn like 100 instances and they just miss one of the instance types and they are spinning up an instance that's going to cost them like, I don't know, $10,000 a day. this is not going to be very good. So that's why you need policies. Atlantis, as far as I know, doesn't have a drift detection mechanism, but still, again, it's a very great product if you are starting out and if you have a very, let's say, not very small, but a small infrastructure that you're going to manage.
And of course, you also consider the fact that you need to also maintain the Atlantis itself too. So a lot of people constantly, they don't, like all the time, they don't think about the operational cost and of course the operational burden of running a project. So when using Atlantis, please just make sure that you have the bandwidth to manage the Atlantis itself too.
Yeah, 100%.
Yeah.
Let's see if we missed anything, Emin.
I don't think so, but there are no questions. Thank you management with IaC really easily.
Yeah, it was a pleasure, guys.